Yes, today we'll see the program. It's about sound programming on length of the string. So here, before starting, we know already that whenever we type the program, we have the initial setup like opening the project and choosing the processor, on processor, which model we have here STM32F401 series. So these are the basic stuff which has been already explained in the data processing experiment as well. So this string experiments, we have three types. One is finding the first one is length of the string, and the next two experiments we'll see in the next video. So now let us concentrate on the length of the string. So when we start with the initial line, first line of the program, you can see that it is given as area, data 1, data read only. So this indicates that whenever we talk about a memory, we know it can be either a program memory or data memory. So initially, as we say that the program is for length of the string, it indicates that there are some set of characters which is already loaded in the program, and those characters has to be counted in the string. So here, when we say area, so this indicates the second one is data memory. So we have written as data 1. So area is one of the assembler directive, which is followed by data 1, which indicates it's connected to the data memory. And again, we have another assembler directive data and read only. So when we say initially read only, it indicates that we have a string which is available, which has to be read. And the next instruction indicates that store str. So store we have used and we have indicated with the assembly directive again DCB. So DCB is, it is defined constant byte. So because why we use the word DCB? Because we know that we have different set of assembly directive DCB or DCW or DCD. So DCW is used for basically used for word, and DCD is used for W word. So here we use it for DCB as a byte because the individual character what we have, say for example VI. So V is an individual character, so it will be converted to equal ASCII value because in a memory window we can't move the character. So we are converting this V into a equivalent ASCII value so that we can see while executing the program. So this is how we are fetching the value. The data given as VA, TT, AL, V. So it is just a mixing of characters. I have not used any common word. And initially it is set to 0. Now next again it is used as a assembly directive which says that align, that is so align indicates that it is, it aligns the current location to a specified boundary. Okay, so initially it is set to 0, so that is what it means to say. Now let us go to the program, and we have the next, again we have opened another area which is also connected to the data memory, saying that we are going to read write. So that means we have already fetched the data as BATTALB, but after the data, the character in the string has been counted, it has to be rewritten in some other place. So we have again opened a label called as count with the DCB. Again it's going to be byte value, so DCB, and it keeps incrementing based on the number of strings we have loaded. Say for example we have loaded here 7 characters in the string, so it has to be 7. Okay, so this is how we use the concept as read only and read write. So read only is just fetching the data, read write is already count what is going to affect in the data memory. Next is your actual code. So again we are going to open a segment called as area, which is assembly directive, and we are going to give a name as a program because it's connected to the program code. So we are using this program memory, and it means we are utilizing the program memory. Then we have code and read only. Means these above two condition indicates the data, and the below condition indicates it's going to be a code which is being followed. Again it is going to be a read only, means you are just going to execute the instruction. Then next instruction is followed as an entry. So this indicates as an entry level point, and again from where you are going to start the program. So normally here it will be initial as export start, but as we are connecting with your STM file, so we have to locate the this condition underscore main from your source code file. You can see here it is connected here with the line number 180. So we are going to just copy this link from your source code file. It means your source code file is linked with your STM file. So your start file and source code file should be similar. Either you can use your start or you can use your underscore main. Anything is fine. So if you are using your start, again the program also it should be start. So as we used in the source code file here, as mentioned here, we are going to have it as underscore main. So next follows the main program. So initially we know that we have the instruction called as LDR. So LDR is an instruction which is used. It is set as LDR load register with word. So here the data which is being fetched here VATTARB will be loaded onto the is linked on the register R0. Okay. Now whenever we want to put some value into a particular register, here we are indicating that R1 will be the register where we are going to count the number of characters in the string and load it initially in the R1. Then later on it will be moved to R3 register. So as we know that the data counting the counting the characters in the string will be affected in R1. So we need to clear the R1 to 0. So we use an instruction exclusive OR which indicates that when we do the exclusive OR between R1 and R1, it will clear the register and it will make the R1 to be 0. So we are making the register R1 to be ready to keep counting the characters and put it in R1 initially. Then we are opening a label with a loop. Okay, and you can see all this label is being left aligned so that indicate these are the label. The next one is LDR byte. So here we know we are going to use individual byte. So we are going to use byte wise. So one by one byte we are moving. Now we know that already the program is being linked with your characters being linked with the register R0, which is being fetched here as data 1, means from this memory, and then it is being connected to R0. So we say your data is already available in R0. So and it is given as LDR byte. So we are going to initially move only one byte, that is say for example V, and it will have an equivalent ASCII value as well. So one byte is being moved to R2. Now you know that your ASCII value of the corresponding character V is now present in R2. Now this R2 is now it is going to be compared with 0, because once you execute the initial 3 instructions, all these characters will be converted to ASCII value. It will be kept in the memory. It will be kept in the default memory. So already ASCII values are present in the memory. You are just going to fetch the values. So it will start fetching the value. So now imagine I told you here 7 characters are there. So 8th character will be 0. So initially it will compare what is the value of R2. So now we know that some corresponding values are an ASCII value. So it will be comparing with R2. You know it is not going to be 0 because already we are moving fetching a character B which is having an equivalent ASCII value. So it will say it is not 0. So what it will do? It will go to the next one to say that add R1. It means your R1 is being incremented with 1. It means one character is being counted. Then again we are going to execute the next instruction V loop. So branch loop. So branch loop means again you are going back to the loop. Again you are going to fetch the next character I. So like this the process will continue till it will reach the last character. Again it is going to the 7th character V. So once it reaches the 7th character V, it will compare, and after executing again it will go back to the loop. Means from after executing 7th character, again it will come to the V loop. Once it comes here, the 8th character will be obviously there is no character, and the ASCII value also will not be present. It will be just default memory window also 0 0. So now it will say compare R2 0. So once it says 0 0, it means the next instruction is branch if equal. If compare R2 is equal to 0, then it has to go to the loop done. So what this sorry to the label done. So here in done label, it indicates it executes instruction LDR R3 is equal to count. You know the count is connected to the label with the assembly directive DCP0. It means you have already counted the characters and kept it in R1. So we want the value to be moved to R3. So we are initiating a label called as count, which has to be connected with R3. So when we use this value count, it is also assigned with a specified address. Means whatever the number of characters counted in R1 has to be moved on to R3. So for that we are initiating with the label count with the address. So again the address will be randomly chosen. So we can see some, say for example 2000 270 zeros. In that particular address, whatever the characters they counted, say for example 7 characters, it will be loaded with the value 7. So initially now it will just assign the label, but it will not load any value to the R3. Now, but we know that the result is available in where it is available in R1, because we keep incrementing R1 by with this once you complete the execution of all the characters. So now the result is available in R1 by incrementing every time by 1. So R1 will have a value obviously 7. So that will be moved on to R3. So when I say moved on to R3, R3 is already linked with the address, memory address, say for 2000. So your address, the value what is there in R1 will be moved on to R3, which is again connected with the location memory address 200070. So this is how you are getting the end result of the length of the string. Let me execute and show it to you. So just tell me. So I'm doing step by step. Yes. Initially your R0 is initialized with the data 1 memory. It means your data has to be moved to the memory window what is set here. So what is the initial memory it is taken? It is taken as 08 000. So I'll say 08 135. Yes. So you can see here this 56 to 56, that is 56. The equivalent value of B, first character B is 56. Again I is 49, and again T is 54, and again another T is 54. So repeated, you can see T is repeated twice, so it is 54. Again 41 is for A, and L is for C. We know already the first character is B, that is 56. Again it is going to be repeated to the last. So here already the ASCII value is fetched and it is kept into the memory. That is the random address which is generated in the R0 register. So we can see the ASCII values is already kept here. That means the characters being converted to ASCII value and stored in the memory window of this address. Okay, so this is a random address. You just type the address what is given in the R0, you will get the values here. Now you can see the next character of P is 00. Okay, so as I told you, once it counts all the characters. Once it repeat the loop, compare R2 is equal to 0. What will happen? Your R2 will be now loaded to 0. So it means once it's compare R2 is equal to 0, then it will execute branch filter. That means you have counted all the characters. So when I do this execution, yes. So if the first character is fetched, that is the equivalent value of B is, the equivalent ASCII value of B is 56. So that is being fetched and kept in R2. So that is why I told you R2 is being fetched with the character R2, and we know that R2 is not equal to 0. It is having a value 56. So like this, it will repeat. Then again, it will execute branch equal done. No, it is not equal. So it will go to the next one to increment R1. So now R1 is initially 0. So you know that R1 is a register where we are going to count the number of characters and kept it in R1. So now it is being changed as 1. It means the first character is being counted, and it means the program is for counting the length of the string. So the first character in the string is counted. So like this, again the equivalent value of I is 49. That has been moved on to R2. Again it is going to compare with 0. Now it is not equal. So again increment R1. Yes. R1 has been incremented. So that means second character is counted. So like this the process will go on till the 7th character. So let me give run. So every time you can see there is a change in the value of R1, and as well it is also fetching the value of ASCII value to R2 register. So you can see still R3 has not been loaded with any final answer value because still it has not finished the counting of the string. So it has almost reached 5. That means it has counted 5 characters in the string. So it has reached 6. R1 is loaded with 6. It means the 6 characters are available in the data what you have feeded. Yes, 7 characters are counted. So now when it executes, compare R2 equal to 0. Yes, it is equal to 0. Branch equal done. Now this instruction will be executed. So it will go to this R2 R3 is equal to count. So now as I told you, R3 is linked with the label count. So you can see in R3 there is a memory address 0x200. So let me give it as, this is the input. Whatever you given 0800001D5 is input. Now we want the output, which is the characters which is counted. So it has to be loaded in the memory location. It's given here 270. So let me type it here 200 in memory window. Yes, it is 7 zeros. Oh, 6 zeros. Yeah. Let me execute the instruction. Yes. So once I execute this, you got the result as 7 here. It means your R3 is linked to the memory address 2000, which is having a value as 7. It means you are not loading the R3 with 7, but R3 is linked with the memory address with the label count, that is 200 will have a value